Suppose you have borrowed a 3-year loan of rupees 10,000 at 9% from your employer to buy a motorcycle. If your employer requires 3 equal end of year repayments, then find out the amount of annual installments. Also, prepare the amortization schedule. So this is a case of loan amortization. Let's understand this better by drawing it on a time scale. So the tenure here is 3 years. So 0, 1, 2 and 3. The amount of loan taken is 10,000. Rate of interest is 9%. And we need to make payments. So let's say the amount of payment is PMT. When using the formula, this is also denoted as A. A stands for the annuity amount. So let's look at the first method to solve this example. Now this loan amount can be broken down into 3 components. Let's say PV1, PV2 and PV3. Now this PV1 will get converted into the first payment installment. The second PV, that is PV2, is going to get converted into the second installment of payments, and this PV3 is going to get converted into the third installment of payments. So basically PV1 plus PV2 plus PV3 is equal to this 10,000 rupees. So PV1 plus PV2 plus PV3 is equal to PV, and this PV is nothing but 10,000. So let's now find out the values of PV1, PV2 and PV3. So we know that future value is equal to present value into 1 plus I to the power n. Now as per this formula, if we consider this on the time scale, basically this PV will take values of PV1, PV2 and PV3, and this FV, that is future value, is nothing but the payment amounts which we are going to pay in installments, and these are nothing but the payment amounts which are going to be the same for all the 3 installments. So our PV1 becomes FV divided by 1 plus I to the power n, and FV is nothing but payment. Similarly, PV2 is payment divided by 1 plus I to the power n, and so on. Now I in case of PV1 is 9% and n in case of PV1 is 1. I in case of PV2 is again 9%, but n is 2, and for PV3 I is 9% but n is 3. So this becomes PMT divided by 1 plus 0.09 to the power 1 plus PMT divided by 1 plus 0.09 square plus PMT divided by 1 plus 0.09 cube is equal to PV, which is 10,000. Or so we can take PMT as common. So we get 1 divided by 1.09 plus 1 divided by 1.09 square plus 1 divided by 1.09 cube is equal to 10,000. So 1.09 cube is equal to, and this is 1 by x plus 1.09 square 1 by x plus 1.09 1 by x is equal to, so or PMT into 2.53 is equal to 10,000, or PMT is equal to 10,000 divided by 2.53, 10,000 divided by 2.53, so 3952.57 rupees. Now let us move to the second method, which is to use the formula for present value of an ordinary annuity. Now the formula for finding the present value of an ordinary annuity is PV is equal to A into bracket 1 divided by I minus 1 divided by I into 1 plus I to the power n. Here we know the present value, which is 10,000. We know the value of I, we know the value of n, and we have to find the value of A, which is nothing but the payment amounts. So let's plug in the values. So 10,000 is equal to A into 1 divided by 0.09 minus 1 divided by 0.09 into 1.09 to the power n, and n here is 3. Or, so now let's calculate this bracket. So we'll first take this part. So 1.09 cube into 0.09 and 1 by x, this is negative, plus 0.09 reciprocal, so this is 2.53. And again, this is a huge value, so it depends where you want to round it off, at 2 decimal or 3 decimal. In our case, we'll round it off to 2 decimal here. So 10,000 is equal to A into 2.53, or A is equal to 10,000 divided by 2.53. So 10,000 divided by 2.53, 3952.57. So this is equal to 3952.57 rupees. Now let us look at the third method, which is to use the present value factor of an ordinary annuity. Now in the second method, we had used this formula to find out the value of the payments. Now this formula can be broken down into two parts. One is this part, which is the annuity amount, and the second is this part, which has the variables, number of years, and the rate of interest. Now this part is also known as the present value factor of an annuity, and standard tables have been established for different values of n and I. So in our case, n is 3 and I is 9. So let's look at the table for present value factor of an annuity and find out this value. And once you find out this value, basically the formula becomes PV is equal to A into PVFA, or A is equal to PV divided by PVFA. So we know this is 10,000, and once we know PVFA, then we can calculate the payment amount. So as seen on the screen, this is the table representing the present value factors of an ordinary annuity of rupee 1. So in our case, the value of N is 3. So this is 3 here. And the rate of interest is 9%. So this is 9 here. So basically the present value factor is the value at the intersection of this row and this column. So this is the value 2.5313. Now what does this value mean? So this value means that if we have to get rupee 1 as payments for the next 3 years at the end of the 3 years at 9% interest, then we need to invest an amount of 2.5313 rupees at 9% interest. So let us now use this value in the formula to find the value of annuity or the payments in our case. So let us now enter the values. Or A is equal to PV is 10,000 and PVFA is 2.5313. Now as you might have noticed, in the previous two methods we rounded off these numbers to 2 decimal points, so we were getting 2.53. So we were dividing 10,000 by 2.53. However, in the table here we have this figure as 2.5313, which is rounded off to 4 decimal points. So this value is going to be slightly different than the previous two methods. So 10,000 divided by 2.5313. So this comes out to 3950.54. Now in the previous two methods, the answer we got was 3952.57 rupees. So there is slight difference, and that's basically because of the rounding off error. Now let's move to the fourth method, which is to use the financial calculator. Now let us look at the fourth method, which is to use the financial calculator. Now in order to use the financial calculator, we need to take care of 5 main buttons. First one is N, which is the number of periods. In our case it is 3. Next is I, which is the rate of interest. In our case it is 9%. Now while we used the value of I in the formulas, we were dividing 9 by 100, so we were using I as equal to 0.09. However, while using the financial calculator, we have to use the value as 9 itself. The present value is 10,000. Now while using the financial calculator, we have to take care of the sign. So since this is an inflow into our pocket, this is positive. Next is PMT, that is the payments, which we have to find out. Next is future value, which in this case is 0. So let me now pull the calculator. So the method to use the financial calculator is to first enter the value and then let the calculator know what that value stands for. So 3 is N, 9 is I, 10,000 is the value of PV, that is present value. Payments we have to find out, so we'll click this button at the end. 0 is the future value, and now we'll click on payment. So the value comes out to 3950.55. So the payment amount is minus 3950.55 55 because we are rounding off to 2 decimal points. So this negative sign indicates that this is an outflow from our pocket. So because we have taken a loan of 10,000 rupees, we have to make this installment payments to the person or organization from whom we have taken the loan. Now once we know how much is the installment amount, we are being asked to prepare an amortization schedule. So let's see what an amortization schedule looks like. Now while we have slight differences in the answer that we have gotten in the 4 methods, I will consider this as my final answer and use this to prepare the amortization schedule. Now as you can see here, this is the amortization schedule table. We have years, beginning amount, payment, interest, principal, and the remaining balance. So beginning amount is 10,000 because this is the loan that we have taken. Payment is this amount because this is the installment that we are paying. For ease of calculation, I'll round this off to 0 decimals, so I'll consider this as 3951 rupees. So the amount of installment for all the 3 years is going to be the same, which is 3951, 3951, 3951. Now we have to find out the interest, which is a part of this payment for the first year. So the way to calculate interest is the rate of interest is 9%, and this 9% is going to be calculated on the beginning amount for that year. So 9% of 10,000 is 900 rupees. So 900 is the interest, and therefore the principal will be 3951 minus 900, because this is the total amount of installment that we are paying, out of which 900 rupees is the interest. So principal will be 3051. Now while we have made a payment of 3051 out of 10,000, see 10,000 is the principal amount that we have to pay. Now at the end of the first year we have paid 3051 towards the principal. So the remaining balance is 10,000 minus 3051. So 10,000 minus 3051, 6949. So this is 6949 rupees. Now this 6949 rupees becomes the beginning amount for the second year. Payment is the same, 3951, because that is the yearly installment. Now interest is 9% of the beginning amount of that year. So let me clear this. 6949 into 0.09. So 9% of 6949 is 625.41 rupees. Now the principal will become 3951 minus 625.41. So let's consider this as negative, and to this we'll add 3951. So we get 3325.59. So 3325.59 rupees is the principal amount that we are paying out of 6949. So how much is the remaining balance? So this we'll consider negative, and to this we'll add 6949. So we get 3623.41 rupees. So now this is the amount of principal remaining. So this becomes our beginning amount for the third year. The installment is the same, 3951. Interest will be 9% of the beginning amount. So this multiplied by 0.09. So we get 326.11. principal will be 3951 minus 326.11. So this we'll consider negative, and plus 3951. Now ideally this number should be the same as this number, because this is the principal to be paid and we have to pay it off by the end of the third year. It is coming to slightly higher amount, but that is because of the rounding off error somewhere. So this ideally should be 3623.41, and then the beginning amount minus the principal that we have paid as part of the installment of the third year, the remaining balance will become 0. So this is how you prepare an amortization schedule for a loan. Now as you can notice, the interest amount is the highest for the first installment, and the principal amount being paid is the lowest for the first installment. And then the interest reduces while the principal amount increases. So in the first installment, the principal amount was 3051, then it became 3325.59, and then it became 3623.41, whereas the interest initially was 900, then 625, and then 326. So this is an important concept when you are taking any loan, because in the amortization schedule, the initial installments repay very less amount of principal, as most of it is composed of the interest.